Today we're going to be doing Unit 4, Lesson 3, and we're going to continue on with our rules of monomials. Remember, monomials is when it's all one term. It's always being multiplied or divided, okay? So, dividing monomials. Let's look at what this quotient rule says. To divide monomials, we use the quotient rule. So when we are dividing these, our rule will state that we keep the base the same and we subtract the exponents. All right, and I want to explain why this rule works really quick. I'm going to do an example at the top. Okay, so say I have x to the fourth power over x squared. I could do that out in the long form, which would be 4x's on top and 2x's on bottom. And then just remember that anything over itself equals 1. So right here I see x over x and x over x. So those simplify to just equal 1. And I'm left with just 2 x's remaining on top, so x squared. So that's doing it out the long way, or I could have done it the short way, which is just 4 minus 2 is 2. Okay, so really these exponent rules that we're learning, they're not really things that don't make sense. They're shortcuts for doing it in expanded form, okay, to avoid that middle step there. So let's take a look at some other examples, okay? We're not going to use the expanded form. We're going to use the shortcut rule. So x to the fifth over x cubed, the base is still going to be x, and then I would do 5 minus 3, which is x squared. 5 minus 3 is 2. Okay, and that's really it. Let's do number 4 together, okay? So in number 4, I have two different bases. I have an a and I have a b. So what I'm going to do is take the a exponents, 6 and 2, and I'm going to subtract them. Okay, and then with the b exponents, I have 4 and 3, so I'm going to subtract those. And my final answer is going to be AB, where I have 6 minus 2 gave me 4, and 4 minus 3 gives me 1. And I don't actually have to put that 1 there if I don't want to, but I just want you to see that the exponent doesn't disappear on us. Okay? All right. So we've done 1 and 4 together. I now want to do number 3. And for number 3, I circled that box in red, and then I did a big old arrow to the other side of my paper with a note that I'd like for you to write down. That anything to the 0 power equals 1. And again, this might seem weird, but it's something that you've always practiced. So when you were learning division in school, you learned that anything that's divided by itself equals 1. So without even thinking about it, in my first example, you can tell me that 2 divided by 2 equals 1. But I want to show you what that looks like if we're using the exponent rule. So this would be 2 to the 1 power, 2 to the 1 power. So 1 minus 1 for the exponent would give me 0, and anything to the 0 power equals 1. Okay, so you already knew before I told you the exponent rule that 2 divided by 2 equals 1. And now you know why, and you can prove it using our laws of exponents. So let's do example number 2, x divided by x. And you know already anything divided by itself equals 1, but using my exponent rule, I have x to the 1 minus 1 power, which is x to the 0, which is just 1. Okay. And then in example number 3 here, I didn't give it to you as a fraction. I gave it to you the way that you might simplify it using this division rule. So if I simplified something and I got y to the 0 power, now I can just say that equals 1. Okay? So that's a really important rule to keep in mind. And we needed to use that rule for number 3 here. So I am going to apply the division rule that I've just learned, which is I keep my base and I subtract my exponents. So m to the 3 minus 3 is 1. And now I have, oops, I'm sorry, to the 0 power. And now I know anything to the 0 power equals 1. So my answer for number 3 is 1. What I'd like for you to do now is to pause the video, and I want you to try to find each quotient that is remaining here. Numbers 2, 5, and 6. You're going to try those on your own. I have completed number 2. It was pretty simple, just 12 minus 2, and I got k to the 10th power. In number 5, I got a little bit of practice with how to handle more than one variable. So I did color code p to the 7th over p to the 4th. I would do 7 minus 4, and that's where I got my p to the 3rd power from. And then I did the same process with my q's. Now you might notice in number 6 that I did not finish this problem completely. I paused here after doing my initial quotient rule. Okay, so now I'm ready to simplify this. So I have an x, a y, and a z. Okay, so 20 minus 5 gives me 15. 9 minus 9 gives me 0. And 2 minus 1 gives me 1. And a lot of students try to stop right here, but you need to finish simplifying it as far as you can simplify it. I know that y to the 0 power equals 1, so I'm not really going to see that in my final answer. All I'm going to see is x to the 15th power times z. So x to the 15th power times z. And if you multiply that by 1, it doesn't change how the answer looks at all. But if it does make you feel better, you can put a 1 in front, but you usually won't see the 1 in the front. Okay, so that's my final answer for number 16. Now we're going to come down a little bit and we are going to practice this some more, but I'm throwing in some coefficients to go with my variables. So some students start trying to subtract the coefficients, and I need you to be really careful because if you think about this as an isolated division problem, 6 divided by 2, well, 6 divided by 2 equals 3. Okay, so we already know how to do that. I just don't want you to forget that you know how to do that, okay? We treat the coefficients the same way that we would normally treat any numbers. All right, so 6 divided by 2 is 3, and then I have x to the 4th power minus the 3. And so my final answer here is 3x to the 1st power. Okay, let's do a problem that has multiple variables in it. Let's do number 10. So I know negative 15 divided by negative 3 is a it's a positive 5. Okay, and now I have an x, a y, and a z. So for my x's, I have 6 minus 5, which is 1. I have 5 for my y's, y to the 5th over y cubed, so that's 5 minus 3, which is 2. And then I have this z here to the 1st power, and there's no z in the denominator of my fraction, so it just stays how it is. And that's my final answer. Alrighty? So let's go ahead and I want you to try numbers 8 9, and 11. Let's go ahead and give those 3 problems a try. So pause the video while you do that. All right, welcome back. I completed number 8 from start to finish, and I did show my work. 2 minus 1 for the R, and then 2 minus 1 for the S as well. And then 14 divided by 7 gave me 2. So that's my final answer there. I did the first step in number 9. Negative 36 divided by 4 is negative 9. And then I circled the exponents for my C variable, and I got 2 minus 2. So let's bring down what we have. 2 minus 2 is 0. And then my D is 5 minus 3, which is 2. So I'm ready to simplify this, knowing that the C to the 0 power won't be seen. Negative 9 times 1 is still negative 9. And then I've got D to the 2nd power that's still there. All right, so that's my answer for number 9. And then I got number 11 started as well. The ends were easy. I know I have a 5 on top and a 1 on bottom. So I've got n to the 4th power. 5 minus 1 is 4. But I did not yet simplify my 4 divided by 8. So this is where a lot of students start making the mistakes with the coefficients. You see an 8 and you see a 4 and you see a division sign, and you might have wanted to put the number 2 there. But we need to be careful. If the 8, the bigger number, is in the denominator, then when we simplify and reduce this, that 2 stays in the denominator. Okay, so 4 divided by 4 is 1 on top, and then 8 divided by 4 is 2 on the bottom. So actually, my answer here is 1/2 n to the 4th power. Okay, so let's do another one that's just like that. Okay, I need to do 36 divided by 54, and I'm going to do some scratch work over here. 36 divided by 54, and I can divide those both by 9. So let's divide them both by 9. 36 divided by 9 is 4, and 54 divided by 9 is 6. Okay, so I can actually reduce this a little bit more. 4 and 6 are both divisible by 2. So 4 divided by 2 and 6 divided by 2. So this was a situation again where the bigger number was in the denominator. So my final answer is going to include a fraction. Okay, now I'm ready to do the m's and the n's. So I have for m's 9 minus 3, which is going to give me a 6. And then for my n's, I have 5 minus 2, which is going to give me a 3. And now let's bring everything down. 2/3 m to the 6th power, n to the 3rd power. And that's it. Now we're ready to start with our mixed practice. Remember, the mixed practice includes all of the different rules that we have learned, and then they're all going to be put together. Okay? And actually, before we jump into the mixed practice, I added a number 17 example at the bottom. Our Math 1 requirements are completing the exponent rules using fractions as well as integers. Okay, so we do need to know how to do this. We have to deal with the fractions. So my base here is x, and the rule says that we're going to subtract them because this is division. So I'm going to have 3/2 minus 1/2. Okay, now when I have fractions, as long as the denominators are the same, 2 and 2 are the same, then I am allowed to keep that denominator of 2 and subtract the two numerators. So 3 minus 1 is 2. And then um, I need to go ahead and simplify this as well. So I have x, and then 2 divided by 2 simplifies to equal 1. So I have x to the first power. Alrighty? So fractions work the same way as integers. Now we're ready to begin our mixed practice. Okay, so let's go ahead and start our mixed practice. We first are going to do number 13 by remembering our power rule. So let's share this outside exponent with everything on the inside. Remember that our exponents are snobby, so the 3 and the x won't be affected, but their exponents will be. So for the 3, that has a 1. So 1 times 2 is 2, and the x has a 5, so 5 times 2 is 10. Let's carry over the rest of our problem. And then I'm going to go ahead and reduce the 3 squared. That's going to give me a 9, 10, or x to the 10th power over 27 x to the 3rd power. Okay, so now I'm ready to simplify the 9 divided by 27. 9 goes into 9 one time. 9 goes into 27 3 times, so I get a 1/3. And now let's do my x to the 10 minus 3 is going to give me 7. So my 10 minus 3 gives me x to the 7th power. And that's my final answer. I've completely simplified that as far as it can go.
Hey, what's up, people that's watching this video? This is me, Travis. How's it going? Hope that's going well.
Now I'm going to have to edit. Go. All right. I'd like for you to try number 14 on your own. It's the same process as number 13. It just includes one additional variable term. All right, so pause the video and give that a try. All right, welcome back. I've completed example number 14. So I began by distributing my exponent of 3 to all the bases inside the parenthesis. So I ended up with 2 cubed a to the 6th, b to the 12th. And then to go from here to here, all I did was simplify 2 cubed. Remember, 2 times 2 times 2 gives me 8. All right, and so I now have 8 over 4 circled in green, which gives me a 2. And then a to the 6 over a cubed, so I do 6 minus 3, and I get 3. And then for my b's, I had to do the 12 minus 7 for my exponents and get a 5. All right, let's do number 15 together real quickly. So I'm going to start out by distributing my exponent using the power rule. So I have 4 squared. 4 squared gives me 16. So I'm going to try to go ahead and reduce that now. And then I've got w squared, v squared. And that's all under 12w to the ninth, v to the fourth. All right, and now let's reduce this fraction. 12 over 16. They're both divisible by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. And now I have W. 9 minus 2 is 7. And my V's, 4 minus 2 is 2. And let me just add my V. And that's it. Great job. Let's do number 16 together as well, because this is the largest problem here. And you can see that there is a power rule going on both the numerator and the denominator. So I'm going to go ahead and have to distribute to all of the terms in both the top and the bottom. So 2 to the fourth power, 2 times 2 is 4, times 2 is 8, times 2 is 16. And then I have C to the 4 times 1, and I have D to the 4 times 4. Let's do the bottom now. 2 squared gives me 4. So C to the 2 times 2 is 4, and D to the 3 times 2 is 6. And now I'm ready to simplify. 16 divided by 4 is 4. And I'm going to keep the C and the D. My bases don't change. Okay, so C to the 4 minus 4 is 0. And D to the 16 minus 6 is 10. And then I just need to simplify this one step further. C to the 0 power equals 1. So I need to take that out. My final answer is 4D to the 10th power. All right, so we've covered dividing our monomials. Let's go take a look at our very last exponent rule on the right-hand side of our paper. Okay, we're going to be discussing now negative exponents and how we deal with them. So now I do have like a little tip at the top of the paper that's going to help us with the division rule when it comes to negatives. And that is that we can potentially avoid negative exponents when we're using that quotient rule by keeping the variable on the side of the division bar that has the larger exponent. And so let me do this example that I wrote here with you. So I know that the rule would be to do 2 minus 3 and then to simplify that. And that would give me x to the negative 1 power. But here's how I recommend doing it. I would say the 3 is the bigger number, so keep the base on bottom. And then do 3 minus 2. And if I simplify that, I get 3 minus 2 is 1. Okay. Now some students might be thinking, what do I do with the top? So what do we always do? When we need to put a placeholder, we put the number 1. And that's the final answer for that example. I didn't have to deal with the negative exponent. All right. But if you don't see that, and you do decide to work with the negatives as opposed to just keeping it positive wherever it is, let's talk about what this negative exponent rule is. So exponents shouldn't ever actually be written with a negative. If you leave it as a negative, it means that it's not fully reduced. Okay, so I think of negative exponents as like a big old flag sticking out at me. So I always circle it when I see that it's negative. And what that tells me is that wherever it is, if it's in the numerator, it needs to go down to the denominator. Or if it's already in the denominator, it needs to go up to the numerator. Okay, so you might be thinking, I don't have a fraction, but we always have a fraction. Everything can be written over 1. Okay, so what I'm going to do is I show my work by circling it and then drawing an arrow to the other side of the division bar that it should go to. So here's what this would end up looking like. My base gets moved to the bottom, and the value of the number, like if it's a -2, it's going to stay a 2. But now when I moved it down there, it became positive. All right, it becomes positive when you move it down there. Let me just write that a little neater. All right, and then on top, I just need to put a placeholder. So now I have a 1 on top. Sometimes there will be other numbers that are left on the top, and we're going to see that with example 2 here, as well as example 3. Okay? All right, so let's start out by looking at example number 1. So I see a negative, which is a red flag. Currently, I don't have a fraction, so I need to make the fraction. Okay, and I wanted that to be in black. Okay, so let's take a look at example number 1. I see a negative exponent, which is a flag. Okay, it tells me to move it to the other side. So I need to make the other side appear. There it is. And now I'm going to have to move this down. So I have x to the positive 5th power on the bottom. And that's it. I'm finished. All right, let's look at example 2. I see a negative exponent, which is a flag. It's currently not a fraction, so we make it into 1. And then this needs to be moved to the other side. So I now have on bottom, you can keep the 1 if you want to, but you don't need to. 1 times m is just 1m. And then the 2 became positive 2 now. What about the 3? Well, the 3 here does not have a negative exponent, so it stays on the top. Okay? It stayed right where it was. So I just did that in blue to kind of point it out for you. All right. Why don't you try example number 3? Pause the video and see if you can do number 3 on your own. All right, welcome back. I've completed example 3, and the only thing that had to move was the a to the -4 power, so it is now on the bottom. All right, let's jump into our examples. Now, I want you to notice that I've broken these up for you. So the first 4 will be all the product rule, practicing with negatives. The second set of 4 will be all the power rule, practicing with exponents. And then 12 through 15 will be the division rule. All right. So let's start with the product rule. There are different ways of going about this. There isn't really a right way or a wrong way. You are allowed to use the different rules in different orders. It's not like the order of operations where you have to do it one way. So let me kind of just show you what I mean by that in example number 4, okay? So in example 4, there's 2 ways to do it. Way 1 would be just going straight across. W to the 7th times W to the -9th would be keep the base and then add the exponent. So 7 plus -9 is going to give me a -2, which then is a flag telling me to move that to the bottom. So that's one way to handle it. Another way to handle it would be to deal with the negative first, some people prefer to do it that way. So if I take the W to the negative ninth power and just move it to the bottom and keep the W to the seventh where it is, now I can use my quotient rule and that little trick that I taught you up top. The 9 is the bigger exponent, so the W will stay on the bottom. And then I can do 9 minus 7 and get 2, and then use a 1 for a placeholder. So I did these in very different orders, and I even used different rules. One used the product rule, way number 1, but then method number 2 used the quotient rule. And they both got me to the same answer. All right, so as we're working through this, people might solve things in a little bit of a different way, but we should still be able to get to the same final answer. Okay? Now, I like to try to avoid negatives as much as possible. So I tend to do method number 2, which is going to bring all my negatives to the bottom first. Okay? And that's how I'm going to do it in example number 5. So in example 5, right away, I see 4 and C to the 8th power. They're all positive, but then I have this D to the negative 3rd power. So I need to move that to the bottom. D cubed. Now, bring down that multiplication sign. And then I have a 5 on top that has a positive exponent. But then the C and the D both have negative exponents. So I'm going to move those both to the bottom. So that was C to the negative, what was that number? It was, okay, I need to erase that so I can see. Okay, C was to the 5th power. Okay, because I had to move it down, and D is a negative 1, so I had to move it down. Okay, and now what I have is just multiplying straight across because I have this fraction. And multiplying 2 fractions. So 4 times 5, 4 times 5 is 20. D cubed and D to the 1st will be on bottom, so that's D to the 4th power. And then I have these C's. I have one on top and I have one on bottom. So 8 is bigger than 5. So the C is going to stay on top. And 8 minus 5 is 3. So that's my final answer. 20 times C cubed divided by D to the 4th power. And I know that that was really crazy. It just takes some practice. Okay. So what I'd like for you to do is pause this video. Pause the video and give this number 6 and number 7 a try. All right. And then come back and then check in with me. All right, welcome back. I did my first step, which is just moving all the negative exponents to the denominator. All right. And now I'm going to go ahead and simplify what I have here. 6 times negative 3 is negative 18. And then on bottom, I have a base of x, and I'm going to add 8 plus 3 and get 11. In number 7, I have a little bit more going on. Let's see. I have let's start with the A's. Okay, I'll do this way. So I have A to the 7th power and A to the 5th power. Well, the 7 is bigger, so the A will stay on top. And now I'm going to do 7 minus 5, which is 2. Next, I have C's. So I have 12 on bottom and 7 on top. 12 is bigger, so the C will stay on bottom, and then 12 minus 7 is 5. And now let's do the B's. I have B to the 8th on top, B cubed on bottom. 8 is bigger than 3, so B will stay on top. 8 minus 3 is 5. And that is my final answer. All right, let's take a look at how negatives work with the power rule. So I'm going to start with, let's see, I think I'm going to do number 8 and number 11, and then have you all try 9 and 10, okay? So when I see a negative exponent outside of a parenthesis, I can treat it just the same way as that red flag. I can take that negative exponent and say that everything inside that parenthesis needs to go to the bottom. And so here's how that would look. Okay, so I have 8p to the 5th. And now instead of that -2 exponent, it's now positive. But I need to remember to put that placeholder. Okay, so no more no more negatives. I'm done with those. Now I can do the distributing like I'm supposed to. Okay, so my bases are 8 and p, and I have a 1 on top. So remember, snobby exponents only talk to other exponents, so 2 times 1 is 2, and p's 5 times 2 is 10. And now I just need to simplify the 8 squared, so it's 1 over 64p to the 10th power. And that's my simplified answer. All right, I want to do number 11 differently. I want to show you if you choose to distribute the negative, what that would look like, okay? So I'm going to start by distributing. That's 6 to the 1st power. So 6 to the -2, x, let's see, that's a +5 and a -2. +5 and -2 gives me -10. And then my base of y. -4 times -2 is 8. Negative and negative gives me a positive. Okay, so I've simplified that. Now I'm ready to deal with my red flags. Okay, so these need to get moved to the bottom. So let's make the bottom happen. Now the y to the 8th, that's going to stay right on top. X to the -10. It's going to come down, and that 10 becomes positive. Okay, 6 is going to come down, and that 2 will become positive. And then the last thing I just need to remember to do is to simplify the number here. So 6 squared is 36, x to the 10th, and then on top I still have the y to the 8th. All right, so what I'd like for you to do now is to pause the video and try numbers 9 and 10 on your own, and you can do it whichever way that you would like to do it. The way I did it in number 8 or the way I did in 11. All right, welcome back. I completed number 9 by dealing with the negative exponent first. And then I did number 10 doing the distributive property first. All right, so here's how I kind of decide when to deal with the negative first or when to deal with it after distributing. If there is a negative exponent inside the parenthesis as well as above the parenthesis, that's when I distribute first. All right. Okay, we are now ready for how do negative exponents work with the division rule, and I've kind of already addressed this. Okay, so I see h to the 5th on bottom, h squared on top. So the 5 is bigger than the 2. 5 is bigger than 2. So what I'm going to do is keep the h on bottom. And then I'm going to do 5 minus 2 gives me 3. And I just put a placeholder up there. All right. Let me do number 15 and 16, and then I'm going to let you finish up 13 and 14 on your own. So in number 15, I see that I have a negative 10 divided by 2, so that's just going to give me a negative 5. And I do have this fraction going on here. Okay, so negative 5 over 1 is the same as negative 5. My m's, let's see, a 3 on bottom and a 2 on top. So I'm going to have m stay on the bottom, and the 3 minus 2 is 1. And then for my n's, I have n to the first power and n to the negative 5 power. So positive 1 is bigger than negative 5. So the n will stay on top. And then this just requires me to think about for a second here. Okay, what is 1 minus negative 5? And the answer is 6. All right, the answer is 6. Got to remember those integer rules. And now I'm going to do 16. So I have x to the negative 1/2, and I also have x to the positive 3/2 on bottom. So because positive 3/2 is bigger than negative 1/2, the x will stay on bottom. And then I'm going to need to do 3/2 minus negative 1/2, which of course means I'm going to end up adding them together. 3 plus 1 is 4, over 2 is 2. So now let me write what this final answer will look like. X squared on bottom, and then I got to remember that placeholder on top, and I'm done. So go ahead and pause the video and then come back when you've completed 13 and 14, and then you can compare your work with my work. All right, so welcome back. You've completed examples 13 and 14. I've gone ahead and shown all the work that I could, keeping in mind that we take the larger exponent for the c's, which is 7. So c will stay on bottom because that's where the exponent with the 7 is. And then subtract the negative 2. So I didn't use parentheses, but I was certain to show that I was doing minus a negative 2. So 7 minus negative 2 gave me c to the 9th power. And of course, I did the same thing with the d in the numerator. Example 14 included some coefficients. So 14 divided by 7 is the same as 2 over 1. And again, the positive 4 is larger than the negative 2, so the w will stay in the numerator, and then I do 4 minus negative 2, which gives me a positive 6. And this should be a w right here. My smartboard decided not to work properly, so just keep in mind that's a w. All right, that's it. There is a practice assignment posted for you on Google Classroom. Be sure that you get that done either in class or for homework. Until next time.